I think most of the engineering community around the world know what a control system is. What I want to cover with you is probably the more advanced uses of a control system and the different types that you use. And I want you to touch on kind of bringing it away from your Formula One background into modern industries. So let's start from the top with what is a control system as you know it? What is a control system as you know it? And second question is, what is your role there as a senior control systems engineer?
Yep, yeah, sure thing. So I guess a control system is essentially used to regulate behaviour of itself or another system to achieve a desired goal. So typically they consist of both sort of software containing algorithms, logic, control laws, and then hardware, which sort of includes the processing unit, sensors, actuators, and communication interfaces. Control systems can be either open or closed loop, sort of depending on whether there's feedback or not. And feedback is where sort of sensor data is used as an input into the controller, and the controller then uses that data to adjust its output accordingly. Similarly, the role of a control systems engineer is to design and develop and integrate these systems. It's a role that requires a multidisciplinary skill set, so controls, systems engineering, performance, software, and even electrical engineering. And often these control systems have significant safety responsibilities and functionality alongside needing to meet performance and robustness.
So how transferable, I mentioned F1 earlier, how transferable are the tools and the processes that you use in your control systems for industries that don't necessarily use that advanced type technology and control systems?
Yeah, it's a good question. I mean, in my opinion, the basic framework, processes and methodology is broadly the same, sort of irrespective of industry. So that's sort of understanding sort of the problem statement, identifying relevant standards and functional safety aspects, developing the concept, then maturing the design, verifying design through test, and sort of using sort of various in-the-loop methods. Integration of software and hardware, validation of the system, and then eventually deployment into the field. And the differences between industries sort of come sort of within that sort of broad sort of process flow, and so application specific sort of subtleties and things like that are demonstrated within the way that you apply the process rather than the actual process itself. Whether it's in the same industry or not, every control system tends to be sort of have some level of bespokeness to it, because it has to be tuned specifically for the activity it's going to perform.
So give me the most advanced version of the F1 version of a control system, just so I can set a benchmark, obviously a high benchmark, but so I can set a benchmark.
So I mean, one of the most complex components within a Formula One car is the power unit. It's got it's a turbo combustion engine alongside a battery unit, and those two components have to work in unison to optimize performance. And so within that, you need a control system that will not only manage sort of battery deployment, but also the recharging from the MGUK and the MGUH, and then also sort of monitor temperatures, injector timing, sort of understanding sort of cooling requirements and how and when it can't throttle itself up and down, and then also sort of manage inputs from the driver itself as well.